Hello.
Hello, sir. Have you started your
Good
lecture?
evening. Yeah, sir.
Yeah.
I start my lecture. Okay.
Yes.
Okay. Okay. My voice is audible, sir.
Yes, sir. Perfect.
And PPT is visible.
Yes, sir. It is also visible.
Okay. Okay. Okay, sir. Thank you. Now I start. The PDE inbuilt start. Now today we discuss finite difference method. So we know that if we so use the numerical method and we use the discretization method, mainly people can be use a finite difference, finite element, and finite volume. So how to use finite difference method is nothing but a time dependent PD then we use geophysical fluid dynamics problem that we use Maxwell equation, and also we use the finite difference. This is the simple concept, easy to grid method, pretty explicit method. Now finite element is an
Excuse me,
implicit
sir.
approach.
Sir,
Yeah.
excuse me. Your voice is buffering. I think there is a network issue from your side.
Oh,
Low network. Please check
okay.
it if possible.
Okay, okay, sir. I check. Sir.
Yes, yes.
Just 1 minute. Now, okay, sir?
Yeah,
Hello.
it seems to be okay.
Okay, okay. Hello.
Hello.
Now clear?
Yes, sir. Now
Okay.
it is better.
Okay. Now, finite elements. So, finite element is also the discretization method. Finite difference, finite element, and finite volume. So, finite difference is an explicit method. It can be used for regular grids. Finite element is an implicit approach. Matrix inversion, well-founded, irregular grid, and more complex algorithm. And the finite element can be used mostly the engineering problems. Now the third method is a finite volume. So finite volume is a time dependent PD. Finite volume is also a simple concept, but the advantage for the irregular grid, and this method is again the explicit method. So mainly there are three methods can be used for discretization of the boundary. If the boundary is a regular grid or a irregular boundary shape. If the regular boundary shape, then easily we apply the finite difference. But if the boundary is irregular, then we use a better finite element compared to the finite difference. Now, what is the basic idea for the finite difference? So, the finite difference is approximating the derivative with a different quotient from the Taylor series. So, we know that what is the Taylor series and how defined the approximating of the derivative. So in that case, the finite difference, if we consider the one variable, then we choose the mass size is a delta x. If the one dimension, then we choose the size is a delta x. So if u is a dependent, then uj is nothing but u of j delta x. Now, if we use the approximation, so obviously we define the forward difference, backward difference, and the central difference. So forward difference is nothing but uj plus 1 minus uj upon delta x. Backward difference is a uj minus 1 upon delta x. And the central difference is a uj plus 1 minus uj minus 1 upon 2 delta x. So all the first derivative approximation, forward difference, backward difference, and central difference. Okay. Now, we know that how to apply the Taylor series expansion. So if we consider the function x plus delta x and we apply the Taylor series, then the Taylor series is nothing but ux plus u dash x into delta x plus u double dash x into delta x squared divided by 2 factorial. That means 1 by 2. Then u triple dash, then delta x cube divided by 3 factorial, that means 6, and the remaining term is order of delta x raised to 4. Similarly, if we consider u of x minus delta x, then ux minus u dash x into delta x plus 1 by 2 u double dash x into delta x square minus 1 by 6 u triple dash x into delta x cube plus order of delta x raised to 4. That means the remaining term. Now, using the Taylor series expansion, we write u dash x is a ux, u dash x is nothing but we write ux minus delta x divided by delta x plus the remaining term. Again, if we use x plus delta x Taylor series, then we get u dash x is this ux plus delta x minus ux upon delta x plus the remaining term. And third one is a u dash x is a x plus delta x minus delta x upon 2 delta x and the remaining term. Now the first term is nothing but the backward difference. This one is the forward difference and this one is the central difference. So all three equations can be used for the first order derivative approximation. Using the Taylor series expansion, we define u dash x for forward, u dash x for this one is a backward, this one is a forward, and this one is a central. Similarly, if we use the second order derivative approximation, then the central difference we write uj plus 1 minus 2 uj plus uj minus 1 divided by delta x square. So we know that the Taylor series expansion and we define u double dash x. So we get u double dash x is a ux plus delta x minus 2ux plus ux minus delta x upon delta x squared into the remaining term. So all the basic idea how to define the, how to write the first order derivative and the second order derivative. Now, now we discuss what is the finite difference method. Finite difference method is obviously the discretization form. So we divide the interval x into subinterval, each of which we consider h. Similar, we divide the interval t into subinterval, and each of which is we consider k. So in this graph, in this figure, this consider we x direction and this is a t. Now this is the regular boundary. We discretize, then this value for x is equal to, suppose we consider this is x is equal to 0, then the next value is x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4. Similar, for t equal to 0, then t equal to 1, t equal to 2, t equal to 3, and t equal to 4. So we discretize, then we get the point, we get the node. This node we call 1, 1. Then this node we call, if we write uxt, then 2, 1, 3, 1, 4, 1. Similarly, x is a 1, t is a 2, x is a 2, t is a 2. So whole discretization, we define all the nodes. So a grid of the point is used for a finite different solution. Finite different solution can be represented with the Tij. And Tij means T of xi into Tj. After that, replace the derivative by the finite difference formula. So basically, how to calculate, how to start the any problem is given and we apply the finite difference. So first we decide that the number of variable. After that, we discretize them, and then we create a one mesh, and we define the all nodes. So replace the derivative by the finite difference formula. Suppose our derivative is a second order partial derivative, and we use the central difference formula. So basically what is going on? So del square t upon del x square, we use the central difference. So we write 1j minus 2tij plus ti plus 1j upon delta x square. If we consider the delta x is a length h, so we write t of I minus 1j 2 tij plus ti plus 1j upon h square. So we use the second order derivative and we use the central difference formula. Now for the first order derivative, if we use the forward difference, so forward difference, then we write del t by del t is t of ij plus 1 minus tij upon delta t. If we write t ij, if we change in x, then we change in I, and j is indication for t. I is an indication for x and j is an indication for small t temperature. Sorry, small t time. Capital T is a temperature. Now, after that, the explicit method. Okay. After that, there are two methods for finding the solution. Suppose if we consider the one dimension heat equation. So the first method is an explicit method, and second one is the Crank-Nicholson method. But in explicit method, simple method, but it is the problem for inner stability. And why Crank-Nicholson is important? Because the Crank-Nicholson involve the solution of the tri-diagonal system of equation, and this is nothing but the stable. So the explicit method stability problem is there, but in a Crank-Nicholson method, the method is just stable because the solution is defined in the tri-diagonal system of equation. We solve the system and easily we get the answer. So Crank-Nicholson is better compared to the explicit. Now first we discuss what is the explicit method. So suppose if our problem is a one dimension heat equation, del T upon small del T, capital T is a temperature, small t is a time, uh, small x is indication space, and we know that the heat equation is derived from the heat transfer. So this is a simple energy equation. Now in this equation we apply the explicit method. So in the left side del T by del T we use the forward time, and in the right hand side we use the central space. So explicit method for particularly heat equation we call the forward time and central space. The short form is a FTCS, forward time central space. So we replace the derivative with T of x, T plus K minus TXT divided by K. And the central difference for the second order partial derivative we write T minus 2txt plus t x plus h comma t divided by h square. So we define this term. So t of x t plus k minus txt k upon h square, then the remaining term is there. Now the k upon h square we consider a lambda. So we write this equation in the form T of x t plus k is equal to the lambda T of x minus h comma t 1 minus 2 lambda txt, and the last one is a lambda x plus ht. So this form can be used for developing the Matlab, nothing but the equation for finding the nodes of the problem of heat equation with the initial and boundary condition. So when we use a forward time central space, we get this is a important equation, and using this equation we define the solution for the remaining all the nodes of the finite difference. Okay, how do we compute? So we know that this equation, what is the meaning that we discretize x space and the time, and we define the mesh, we define the grid. Then suppose our grid is this, as for example, this is the grid. Now the boundary condition is given, that means all this point is given, because we consider this is x is equal to 0. And suppose we consider this is the x is equal to end point. So this is a starting and this is the end. Now this value is a t equal to 0. So this line is indicate the initial condition. So there are three main parts. The first is this is the boundary condition left side. This is the right side boundary condition, and this one is the initial condition. So if we know that this point, and this point, these 3 points, using the explicit method, we find this one. That means if we know that this value, and this value, using 3 points, we get this value. That means we get this node. Then we use 1, 2, and 3 node. Then we find this node. Similarly, we continue the process. We get this value also, this value also. Then this whole the discretization point, nodes point, we get the solution. So the basically finite difference and the explicit method is doing the work is this type of form, and we use the forward time and the center. Now the convergence and the stability of this finite difference explicit method, then we know that this is our equation, and this equation is stable if 1 minus 2 lambda is always greater than or equal to 0. That means lambda is a less than or equal to 1 by 2. That means k is a less than or equal to h square by 2. This means that k is a much smaller than h. K is a much smaller than h. So the convergence, the solution is convergence means that the solution is obtained using the finite difference method approaches the true solution at the step of delta x and delta t. Approach to 0. And the stability, and the algorithm is stable if the error at each stage of the computation are not magnified as the computation progresses. So basically, when the method is stable, if the lambda is less than 1 by 2, that means k upon h square, h square upon k is greater than 2, k upon s square is less than 1 by 2. Then this method is stable, otherwise not. Now, we discuss the one simple problem, heat equation. So the heat equation whose length is x is equal to 0, and the x is equal to 1. So x is equal to 0 to 1 is the length of the rod. So this is the equation, one dimension simple heat equation. Now this one is the boundary condition, and boundary condition is says that when x is equal to 0, the temperature is 0. When x is equal to 1, again the temperature is 0. And the initial condition is nothing but sine pi x. Now this problem we solve using the explicit method, and we use the step size for x and t For x, we consider 0.25. For t also we consider 0.25. So if we consider h is a 0.25 and k is a 0.25, then the lambda is a k upon h square. So k upon h square is nothing but 4. But we know that the convergence of the stability of this method is always lambda is a less than or equal to 1/2. So for that case, obviously we can't get the accurate answer. We can't get the approximation solution. So we see in our Matlab program. So suppose our problem, how to define the Matlab program. So obviously first we write the n. N is equal to 5. The value of n is the discretization. Okay. Value of p is also discretization. Nx is a length. Nt is also length of time. Now k is a dx. We consider k is a 0.25 1/4. dt also we consider 0.25. So we write all the value. Now r, that means the lambda. Lambda is nothing but dt by dx square. Lambda is a k upon h square. H is a, that means dx is a 0.25. dt is also 0.25. So we write r is a dt upon dx square. Now some supposition is there, r2 if we write 1 minus 2r, that means 1 minus 2 lambda. So in our equation, when we use forward time central space, so this one is a central space, this one is a forward time. After the calculation we get this equation, and this equation we define the grid and also we define the solution of the each node. So this is the particular example. So we know that lambda is a 4, 1 minus 2 lambda is a 7, and lambda is a 4. But in our program we define the general form. So r is nothing but lambda is nothing but dt upon dx square, and r2 if we write 1 minus 2 lambda. Now this is the indication that when x is equal to 1 and t is a change, this is the boundary condition indication. X is a 1, x is 1. Why we write x is equal to 1? Because in a Matlab program we start with 0 0. We start with a 1 1. So we discretize 1 2 3 4 and 5. Similar way. So this value is a t equal to 0, then t is equal to 0.25, t is a 0.5, t is a 0.75, and t is 1. And x is equal to 0, x is equal to 0.25, x is a 0.5, x is a 0.75, and x is 1. So now this value we write 1 1. This value, the first value for programming we write 1 1. Then this value we write t is 1, x is a 2. So 2 1, then 3 1, then 4 1, and 5 1. So this is a 1 1, 2 1, 3 1, 4 1, 5. Then this value is indication that when t is equal to 2, so x is a 1, so 1 2, then 2 2, 3 2, 4 2, 5 2. Similar way. So now the whole discretization we write in a Matlab when x is a 1, t is a change, x is a 1, t is a change, the boundary condition is 0. Here actually in our program, in our problem, given that the boundary condition 0t, but when we write the program, then 0 we consider 1, and 1 is end of the interval. So in that case 1 means 0, but we write in a program, and the t value is 1 to up to p, 1 to up to 5. So this is the discretization, and all the value is 0. Similar, the end point when x is a n and t is a change, again the value is 0. Now this program, this for loop for define the initial condition. So I is equal to 1 to n, xi is I minus 1, dx is the length, and our function is a sine pi x. So if we write I equal to 1, then xi is equal to 0, so sine 0. I equal to 2, then x2 is a dx, so sine pi 1 by 4. So sine pi by 4, then sine pi by 2. Similar, we discuss here sine pi by 4, sine pi by 2, sine 0.75 by 3. Sorry, 0.75 pi. And last one is sine 1. Okay, sine pi. So we write this function. Now, mainly when we write this equation, obviously we consider the loop, for loop. We start with I equal to 2 because we define the first point. We define this first point, and when we find this point, then we use a 3 value. This one, and this one. That means 1, 1, 2, 1, and 3, 1. So I equal to 2, we start, k equal to 1. So k equal to 1, I equal to 2. We input here k equal to 1 and I equal to 2, we get u22. U22 means this point. This point is a u22. And for finding u22, the requirement is u, I equal to 2, so u11, u21, and u31. That means u11, u21, u31. So if we know that u11, u21, and u31, then easily we find u22. Similar procedure, the I equal to we consider 3, I equal to we consider 4. Okay, so we consider 3 point, we get this value. Then we consider 3 point, we get this value. We consider 3 point, then we get this value, and this is the known value. So we get 3 all. Then again the similar procedure, we get this value. Okay, so first we use 3 point, then we get this. So when x is a 0.25, y is also 0.25. Okay, x is a 0.25, y is a 0.25. We input u00, but in a programming we write u11, then u21, then u31, and we input all the value. We get the manually also possible, because this is very simple problem. We get this value negative. Similar, we use a 3 point, then obviously we get this value, and this value is indicated and t is a 0.25. So we get this value. Then we use a similar third, 1, 2, and 3. We get this value. Okay. So why the our result is not accurate? Because we get the answer is a minus 0.1716, the temperature value. This is not accurate because 1 minus 2 lambda, when we consider k is a 0.25 and h is also 0.25, so our 1 minus 2 lambda value is a minus 7, and actually we get the accurate answer if we consider 1 minus 2 lambda is always greater than 0. That means when we define the accurate answer, then we can't the h is a 0.25 and k is a 0.25 for this particular example. So how to consider the value? So if we consider h is a 0.25, so 0.25 square divided by 2, we get the answer is a 0.03125. So the k value is obviously smaller to the h square by 2. That means the smaller to the 0.03125. So if we choose the k is a 0.025, and then our solution will be accurate. So now we discuss both the program. So here we consider the h is a 0.25 and k is also 0.25. So our equation 1 minus 2 lambda getting the minus 7, and the problem will be not accurate. We will check. Now we run this program. Just 1 minute. So we get this type of solution, but not accurate because our temperature will be negative, and this is not accurate. Now the same program, when we consider dx and dt, we discuss in a PPT. If we consider k is equal to 0.025, program is similar. So 0.025, if we consider k is a 0.025, same program when we run, then we get the accurate answer. So this is the accurate answer. Also we see that this is our solution. Now this solution is indicate that when t equal to 0, x is equal to 0, then the boundary condition 0, This is also 0, this is also 0, this is also 0, this is also 0. And similar, the right hand also, when x is equal to 1, all are 0. Now this value is indicate that when x is equal to 0, sorry, x is equal to 0.25 and t equal to 0. This value is indicate when x is equal to 0.5, t equal to 0. X is equal to 0.75, t equal to 0. So this is the discretization. Now, this value is nothing but when t equal to 0.25, x is changed. This is a t equal to 0.5, x will be 0, 0.25, 0.75, and 1. This value is t equal to 0.75 and this value for t equal to 1. So this is the whole region, whole node value, and we discretize only 4 divided by 4 part and we get the answer. So the basically when we use the explicit method, then this is important. So how to choose the h value and the k value. This is very important because if without 1 minus 2 lambda we consider k and h randomly, then we can't get the accurate answer. Okay, so when we use the similar k is equal to 0.025, then obviously we discuss in a Matlab program, we get the whole answer for a different point. We get this point, all the point we get. Now, this is the explicit method. So in explicit method, the some issue in a convergence problem, in a convergence, but in a Crank-Nicholson method, the why this is better, because the method is involving a tri-diagonal system of linear equation. The method is stable, no magnificence of error. We can use large k compared to the explicit method. So this one is a Crank-Nicholson method. Now before the Crank-Nicholson method also we discussed the some application based example. Suppose our problem is use the explicit method to solve the temperature distribution. Okay. Use the explicit method to solve for the temperature distribution of the long thin rod with the length is 0.05 meter, subjected to the temperature of the 100 degrees on the left end and 25 degrees centigrade on the right end. Find the temperature distribution in the rod from t equal to 0 seconds to t equal to 9 seconds. The following value k dash is a 54, c is a 490, and the density is a 7800. Delta x is a 0.01 centimeter, delta t is a 3 seconds. At time t equal to 0, the temperature of the rod is a 20 degrees centigrade. So all the data is given and we want to find the temperature on the rod at any time, any space. So first, what is the length? So we know that length L is a 0.05. Now K is nothing but the thermal conductivity of the material of the rod is given by 54. So we write K is a 54. C is the specific heat of the rod. So here also given that C is a 490. The density is also given 7800. So all are constant. T1 is 100. 100 is given for the left hand of the rod. T2 is a 25 is the right end of the rod. Initial temperature here given that the fixed value is a 20. So the initial Ti is a 20. Sometime the initial condition is depends on the variable, then we write in the form of the variable. Now the number of the division on the road, that means in a X space we write n is equal to 5, and T for the analyze T we consider 9. So we discretize T is 0 to 9, X is 20, X is 0 to 5, and we discretize the step. So the time step is a 3. Now same problem we discussed earlier. So we define dx, lambda. Lambda means r. Lambda is for the particular example, we know that del u by del t is equal to something lambda del square u by del x square. This is the standard one dimension heat equation. So alpha into dt by dx square. How to find the alpha? Alpha is a k upon c into density. All the value are particularly given. Then we get lambda. We define the coordinate of the node. So this we use the different form, and then we use this equation, similar equation, and we run the program. From all the program is similar to the first one program, only the form is different. Now when we run the program, we get the solution. So this one is the solution. Now how to check the different value? Now we rotate this graph, then we get the boundary condition also and initial condition also, and we this is the indication of the point. Suppose here we click them, then this point is indication when x is a 2, y is a 2, then our value is a 53.91. What is x? X is our x, but y is nothing but t. So x is a 2, t is a 2, then the value of the temperature is a 53.91. Suppose we click here. So x is a 3, y is a 3, the value is 34.37. Now we click here, x is a 4, y is a 1, then the temperature value is a 20. So we rotate and we check all the value of this particular each discretization form. So if we plot them, then also we get suppose this value. So x is a 3, y is a 2, then x is a 3, y is a 3, then x is a 3, y is a 4. So all the discretization form we get the temperature value of the given rod. Now next, Crank-Nicholson method. So obviously we can use the large value of h and k. And this is the similar procedure. Only the difference in a Crank-Nicholson method, based on the finite difference method, we divide x into the subinterval whose width we consider h, divide interval t into the subinterval we consider the width is k, replace the first and the second partial derivative with their backward and the central difference formula. That means in an explicit method, we use the forward time, central space. But in a Crank-Nicholson, we use the backward time, central space. So if we use the same problem heat equation del U by del T, so in that case we use the backward difference, backward time, central space. So this formula can be used for the backward time. This is the second order derivative, central space. We use both the approximation in our one dimension equation. So this one and this one, and then we define the form. So we get the equation is this one. The calculation is very simple. This k we consider in the left side, so k by h square, similar term, right side as it is, and then we define the last term u x t minus k. We get this form. K by h square we consider lambda, so we get final equation is this. So how to calculate all the nodes of the discretization using the Crank-Nicholson? So in a Crank-Nicholson, we can't get the directly answer. In an explicit method, we get directly answer. We use the 3 point and we get the solution. But in a Crank-Nicholson of the equation, and all the nodes equation we convert in a system of linear equation, and then we use the matrix solution, we get the answer. So in this Crank-Nicholson, there are 4 points is involved: ux minus ht, uxt, ux plus ht, and uxt minus k. So the equation is this, can be written as x minus h is I minus 1j, uxt that means uij, x plus h that means I plus 1j, and uxt minus k that means ij minus 1. So obviously we discussed earlier, x is replaced with I and t is replaced with j, h is step size, so minus 1, here x plus h, so plus 1, k is also indication of the step size, so we consider k is 1, so j minus 1 and j. Now this equation first we discretize. Procedure is similar, we discretize this. Okay. Now first we fix j. If we consider j equal to 1, then we get I equal to, we start from 1. J is 1, I is 1. So 0, 1, 0, 1, 1, 1, 2, 1, 1, 0. So when j is a fix, I is a change, then we get the first equation. That means we get the value on this node 1, 2, 3 node, and then this node. Similar, u11, j is a one fix, j is equal to 1, I is a change. First we consider I is 1, then I is a 2, then I is a 3, then I is a 4. So we get total 4 equation. Now we convert in a tridiagonal system, we get this form. So 1 plus 2 lambda u11 minus lambda u21 is equal to u10 plus lambda u01. Then minus lambda 1 plus 2 lambda minus lambda and u11, u21, u31. So indirectly all the equation we write in a matrix form. So we get the tridiagonal system of equation. And we solve this tridiagonal system, we get solution. The solution of the tridiagonal system is procedure. The value of u11, u21, u31, u41 at the point T0 plus K. The compute the temperature value for T0 plus 2K. After computing, now the second tridiagonal system for J is equal to 2. We get this second step, we get this value for discretization value, this one. So again the system of equation is that, and we solve, then we get u1 to u2 to u3 to u4 to. That means what? This one is a first u11, u21, u31, u41, u11, u21, u31, u41, then u1 2, u12, u2 2. Then similar procedure, we get all the value of the nodes. Now same example we solve using the Crank-Nicholson method. In that case we consider h is a 0.25 and k is also 0.25. The initial condition is similar and sin pi x is also similar. So first we write this problem in a Matlab. So obviously first we write central space and backward time. So backward time is this one and central space is this one. So we get k is equal to 0.25 and h is also 0.25. So we get the lambda is 4. And we input here lambda is equal to 4. So after the first, when t is equal to 0.25, so t is equal to 0.25, we get the system of the tridiagonal, this one, and we calculate. Yeah, we solve this system. We get u11, u21, and u31. Similar, when t is equal to 0.5, second row, that means t is equal to 0.5. This all the nodes. Again, we convert in a system of equation, and we get u1 to u2 to u32. Then 0.75, we get u13, u23, u33. and 1, then we get all 1, 4, 2, 3. So this is the solution of the Crank-Nicholson method. Okay, now some program is there how to define the Crank-Nicholson method. So first we discussed the simple earlier, and after converting the matrix form, we solve the matrix form, and we get the diagonal element, and the diagonal system we solve, we get the solution. So now we run this program. Similar way we discussed earlier, only the change is our solution is depends on the system of equation. So this is the our solution. So when we discretize this, so we get this value, initial and condition, and the whole discretization we get the all nodes value. Now the next one is a elliptic equation. So the previously the one dimension heat equation is the parabolic equation. Now elliptic equation, we know that the characteristic form is a uxx plus b uxy plus c uyy plus d equal to 0. And we know that this equation is elliptic if b square minus 4ac is less than 0. So two independent variable, the standard equation is the Laplace equation. And the Laplace equation appear in several engineering problems such as studying the steady state distribution of heat in a body and studying in the steady state distribution of electrical charge in a body. So the Laplace equation, del square t upon del x square plus del square t upon del y square is equal to our function f of xy, where f of xy is a heat source or heat sink and T is a steady state temperature at the point. Now we check this Laplace equation is a which type, parabolic, elliptic, yeah, hyperbolic. So obviously A is a 1, the mixed derivative is not there, so the coefficient B is 0 and C is also 1, so B square minus 4 AC, we get minus 4 and minus 4 will be less than 0, and less than 0, then the nature of the given PD we write the elliptic. So the Laplace equation is a elliptic type of the form. Now the temperature is the function of the position of x and y. Suppose when the heat source and sink is not available, in that case our function f of xy is equal to 0. Now same procedure for finite difference या Crank-Nicholson method. A grid is used to divide the region of the interest. Since the PD is satisfied at each point in the area, it must be satisfied at each point of the grid. A finite difference approximation is obtained at each grid point. So what is the del square t by del x square? We use the central space. And del square t by del y square also we use the central space for y. So both second order derivative we use the central and we define the equation. So we get this equation, and after we write Suppose delta x and delta y we consider same h, then our standard equation of the form is this: ti plus 1j plus ti minus 1j ij plus 1 ij minus 1 minus 4 times tij equal to 0. And we develop the program similar way we discussed earlier, and we get the solution of the Laplace transform. That means this is a Tij, this one is a Ti plus Ij plus 1, I plus 1j, and Ij minus 1, I minus 1j. So total 5 point is include, and we find them, and we get the answer of each node. Now we consider some example. Determine the steady state temperature at L at all the point of heated sheet of metal. The edges of the sheet are kept a constant temperature 150, 0 and 75 degree. So one of the sheet is given. This sheet is a condition is 0. This sheet condition is a 50 value. This for the 100 and this for the 75. Now we divide this region in a 5 by 5 grids. So this type. So now T00 is 0, T10 is a 0, T20 is 0, T30 is 0. Also the all blue dotted node will be a value, and which will be known, and the red value to be determined. So all this, all value T112, T2131, 32, 22, 12, 13, 23, and 33, we find using the equation. So we know that this is the standard equation. So for the first equation is T03, T03, T14, means T03, T14, then T24, then T02, and T12. So 14, 12, 23, 23, and 13. Similar, we consider T03 is a 75, T14 is a 100, T12 is a unknown, T23 is also unknown, and T13 is also unknown. So we get the first equation. Similar procedure, we get the second equation. Then the another, all the equation we define, and we write in a matrix form. The rest of the equation will be this. So the first equation is a 4T1 minus T21, then 031, then minus T12 is equal to 75. So all discretization form, all the equation will be defined, and we write in the form. We get this is the matrix form, and this is the simple matrix. We use any method and we solve the value. We get all the temperature value of the each node. So the all the concept of the Crank-Nicholson method or explicit method, we write in a program in a similar way. This is the simple program, only the discretization form, and we convert in a matrix. We solve the matrix, then we get the answer. So now I stop. Thank you very much. Okay, any question? Hello, Mihar sir.
हाँ जी सर।
Okay, my side this is complete for the
Okay.
crank. Okay,
So
so
just 1 minute, sir. Today there was no discussion from the participant side. So first, I think I need to permit them so that they can
okay, okay,
unmute
no
and
issue.
they can ask any doubt from their side.
Okay,
Yeah. Dear participant, if you have any kind of question from your side, you are permitted to unmute and you can ask from the speaker so that if you have any question, you can clear the concept. Yeah, anyone have any question, you can unmute yourself. Okay. Participant are asking that there is no question. Actually, the explanation was very nice and still once again I want to ask from the participant. Please feel free to ask if you have any question.
okay, okay, no issue.
Yeah.
And if
Either you
after,
can, yeah, either you can put your question in the chat box also. Please
okay, no
put your
issue.
question in the chat box. Uh, sir, I want to ask from the participant side. I think
Okay,
I thought that participant will ask this question, but I was waiting during this presentation. The question is that when we are using any method and
okay,
there is a float, but sometimes we required numerical result in the form of tabular. So if you can present an example how we can get the results in the tabular form, uh,
okay,
so it will be very interesting for all the participants.
okay, sir. Suppose now, just 1 minute. Okay, now my screen is visible.
Yes, sir. Visible.
Okay. As for example, suppose we write the program and we want to in a tabular form. So our program, suppose we write all things we will discuss. Now last one, suppose we write in a tabular form, then we write only u, and then we run this program, easily we get the tabular form. As for example, we run this program, then we get also tabular form directly in a outbox in a command windows. So this is the tabular form, sir. Hello.
Yes, sir.
So this form is indirectly the tabular form. The first column is indicates the boundary condition for the end value when t equal to 0, x is equal to 0. The second one, this value is nothing but the discretization when t is equal to 0, x is equal to 0.25, t equal to 0, x is equal to 0.5, t equal to 0, x is equal to 0.75, and t equal to 0, x is equal to 1. Similar. Now the second, this row is the indication of when t equal to 0.25, x is vary. So x is a 0, then x is a 0.25, x is a 0.5, x is a 75 point, and x is 1. Now third row, we consider t is equal to 0.5 and x is will be changed. Fourth, this row is for x is equal to vary and t is a 0.75, and last one is a t equal to 1. So if it will be required, suppose any real world problem we solve and we want to tabular form, then directly we write this form. This is the all indication of the value of the each node. Okay.
Sir, I mean, we have a command. By using the
Okay.
command in the first column, we have x, and in the second column, we have t, and in the third column, we have functional value or solution value.
Yeah. Yeah. Hello.
Yes, sir.
Sir, please repeat the question.
Question is that the solution of this differential equation is function of two
Okay.
variable t and x. Okay.
Okay.
So we have a simple command. In the first column, we will be the numerical values or the partition of the corresponding to the interval. Suppose
Yeah.
0 to 1, that will be
Okay.
partitioned into the several points. Then we
Okay.
have in the first column we have x, in the second column we have t, in the third
Yeah.
column we have functional value.
No, sir. No, sir. No. Just one
No?
minute. So this is the partition. Just 1 minute. Okay. Actually, this is the whole partition. The first column,
Okay.
the first column, second column, third column, fourth column, fifth column, all are the value of the temperature U.
Okay.
This is the dependent variable. Now all the value is a U, which is depends on the space variable X and the time variable T. Okay. So this value, suppose my question is one rod is there and the rod length is 0 to 1 and the 0 to 1. Now the question is find the temperature value on the rod at the time t is equal to 0.5 and the space is a 0.5. That means what? We want to find the temperature of the rod when time is a 0.5 and the space is also 0.5. So the answer is U equal to, so this value is nothing but this, all the value, the last row is value of U, but the time is 0 and X is 0. This is 0.25, X is a 0.5, X is 0.75 and X is 1. So X will be changed and T we consider 0. Now T is a 0.25 second. This row is indication that the temperature value for T equal to 0.25 and X. So this value is X for X for 0, X for 25 0.5 and 0.75 and last one. Now this is T equal to 0.75, X is equal to 0. That means just 1 minute. Okay. The discretization form is this. Okay. So suppose our output is the last row. Last row output is indicate T equal to 0, X is equal to 0. So this value is 0. Now the last row, this value is indicate when X is a 0.25, T is 0, X is a 0.5, T is equal to 0, X is a 0.75, T is equal to 0, and X is equal to 1, then T equal to 0. So last row for the output is this value indication. The second last row indication for this point, then this point, then this point, and then the last point. Okay, sir?
Okay, sir. Thank you.
Okay. Okay.
Yeah, any more question from participant side if they want to know? Okay.
Okay, thank you. Thank you
Thank
very
you,
much.
dear. Yes.
I,
Thank you, dear professor,
I
for your valuable time, and it was very, really wonderful talk. Many points has been discussed. I think this will be very helpful for all the participants. Still, some of the participants are beginners. They need code of this content as well, PPT, and some more
okay.
content we will provide so that they can use for their future. Okay. So
Okay, no
first,
issues.
we would like to present a certificate of appreciation. The certificate of appreciation is awarded to Dr. Harshad R. Patel, Department of Mathematics, Sardar Vallabhbhai Patel Institute of Technology, Gujarat, India, for his valuable thoughts in 1 week training workshop on numerical methods in engineering and physical sciences with Matlab. And this workshop was organized by Mathematical Thinking Foundation, India. Now, this is the last day, and first I would like to request all of you, please open your webcam so that we can have some screenshots. And also, if you would like to share your views about this training workshop, and if you want to put your opinion, you can unmute and you can share your opinion about this workshop. And also, we welcome your kind suggestions for future also. Please keep open your webcam. I request all of you, please open your webcam, all of you. Sunday Simon and Hafidi Hani, Manan Shah, Emmanuel, please open your webcam. Nisha Mary, Jignesh Chauhan. And also, if you can share your opinion or give some suggestions, we welcome. Okay, in the last 2 days, yeah, Patience Ivan raised hand. Yeah, please, you can unmute.
Good afternoon, sir.
Hello.
Hello, good afternoon, sir.
Very good afternoon.
Yes, thank you for the opportunity. Though I'm a first timer using Matlab for numerical methods, but I'm grateful to the lecturers and the teachers and all through. But the real challenge is the practice aspects. I want to learn more, and also if there are materials that can give me examples of the Matlab coding for some of these topics we have treated, so that one can learn it, practice it offline.
Okay. Yeah, all the content which has been presented in this training session, many of the content has been uploaded on the Google Drive, and remaining we will upload as soon as possible. And also material for 8 and 9. Okay. Also, after this workshop, there is a suggestion from your side for the beginners. We will organize a special session who never use Matlab, so that basic fundamental can be cleared for all of those who are facing the problem. And also for this numerical methods, plotting 2D and 3D, for all type of plotting. This session is also required for all of you because when we have problems which are related to one dimension or two dimension, then and also for the three dimension. So different type of plotting are required, and we must have all the concept must be very clear, so that whenever we have different type of problem, we can easily use for our findings. And basic fundamentals related to Matlab also will be discussed in the coming days. We welcome all of you. We will intimate about these sessions because some of you recommend us to provide this type of workshop so that basic fundamental can be cleared. Professor Sagar, please share your views. Professor Sagar, yeah, you can unmute.
Okay, sir.
Thank you, sir.
Thank you, sir. Thank you for giving me opportunity to talk me for the review. It was a really informative session, sir. I have learned so many things from the number of expert talks, especially from Dr. Sat Patel. Really informative, sir. Thank you. Thank you. That's all from my side.
Thank you, sir. Thank you.
You're welcome, sir.
Professor Ruth. Professor Ruth Kolove.
Hello, sir.
Hello.
Thank you, sir. I'm still a student, so I'm not a professor.
Yeah, I think because it is very hard to recognize that you are a professor or student. I think you are a student because if you was a student and I asked you student and you were a professor, then it was contradictory. So that's why we all are
Okay,
like-minded,
sir.
no problem.
Okay, sir. I really want to appreciate the organizers of this workshop. It's really good. But like Dr. Evans said, some of us, we are just seeing this Matlab. Like me, I've been using Maple. So this is my first time of using Matlab, seeing it. I really appreciate it and I want to learn more. So like she said, if you can get us things that we can read to really, practice all what we have done here, we will appreciate it. Thanks so much, sir. God bless you, sir.
Professor Rajesh. Niruben Patel. Sunday Simon. I know we are a long time connected with each other. If you can unmute Sunday Simon. Many events you have attended at this platform. You are not audible. You are not audible. Simon, please check your mic. Your voice is not audible. Dr. Pargnesh Kumar.
Yes, good evening, everyone.
Good evening.
Sir. My voice is audible clearly, sir?
Yes, sir. Perfect.
Okay. Thank you, sir. Thank you for this opportunity to attend this training workshop, sir. And all the session is very informative and nicely present all the presenters, sir. Thank you, everyone.
Thank you. Diksha is my student, and I would like to please share your opinion because you are very young student. Please don't hesitate. You can unmute. Yes. Your voice is very low. Anyone who want to share your views? Okay. So we have shared the, yes.
Thank you so much, sir, for providing us a platform where we can learn more and more. And this is really very informative workshop for not only for the students, but also for the teachers and doctors, because we are good at one software or for one or two methods, but not for the all methods. So, teachers are always the learners. So it is really very good opportunity for all of us to learn and understand these methods, but we need practice.
Thank you.
So I hope so. Maths Tech Foundation will arrange more workshops on the nonlinear methods for numerical methods for nonlinear coupled equations. That will be much more appreciated.
Yes, ma'am. Thank you for your recommendation. This foundation was established in the month of August 2020, and a very young foundation, but this foundation is spread over more than 50 countries in very less time. And second thing is that almost in every month we have organized at least one event, and since its establishment, first event was organized in the month of April, 3rd April 2021, and since then numerous event has been organized, and we are continue to organize in the same. But right now we are working on the best on the problems suggested by the participants. Many events which we organized was free in the beginning, but sometimes we need to fund also so that we can manage its running cost, because to bear the running cost from one pocket is very hard. Okay, so this is the big problem for us because there is no funding from any side. So mainly sometimes we have to organize event to manage its running cost for the foundation, so that because we invite speakers and honorarium is there and other expenses are there to organize this type of event.
Yes.
Mainly the most of the event we are organized free of cost, so that more and more connections we can establish, we can help each other. This is the platform where we can exchange the ideas, we can help each other, we can collaborate with each other. This was the opinion to establish to this foundation. And there are also, we have some MUs with the different institutes. There are two universities, one from Rajasthan, Purima University, Jaipur, and second is Mizantep University from Ethiopia. And there are two colleges, and three MUs are in the queue. And I hope in the coming days, in the month of July, we have some more MUs with the universities and institutes. And also we are going to establish local chapters. These are very important for our students to cover the, to establish the bridge between our students and for our faculty members and the researchers and scientists who are working in There are different areas around the world, and this this will help us to establish connectivity for local student with the professors and scientists around the world. Thank you very much. And also, if anyone from you are interested to establish a local chapter for students, we always welcome. There is very small formality, and if anyone is interested to sign MUs for your institute, for your university, for your department, this is a very simple process. We always welcome. And if you want to organize any event on your local level with collaboration, because we have organized many events with the collaboration of universities, NITs, and institutes, not only from India, abroad also. So if anyone is interested to organize event with collaboration, MTTF, windows are open. We always welcome, and we always welcome your suggestions, because your suggestions are very important for the MTTF and to establish new connections around the world.
Sure, Doctor. That will be really very appreciated. Your efforts, you are doing much
Thank
more
you,
efforts
sir.
to manage this organization. At the end, I want to share something. I am serving as an assistant professor in King Faisal University, Saudi Arabia. So recently, I joined the Coatings Journal, which is an MDPI journal, as a guest editor. So I would like to invite all of you to submit your research articles if you are interested and that is relevant to your field. The topic of this special issue is design and research of biomaterials. So in the chat box, I am sharing the link for the special issue. You can see the keywords if you are interested. It is related to the tissue engineering, biomedical sciences, and mathematical modeling of biomaterials. So I hope so. There are the persons and doctors and professors from the fluid mechanics research field. So they will be interested to publish their articles. This special issue is open till February 2023. So all of you are invited and welcome to submit your publications. Moreover, you can see my Google Scholar because I have a lot of publications in the field of fluid mechanics. And I have 39 publications up till now. So I would like to share my Google Scholar page with all of you. If you are interested, you can collaborate with me in the fluid mechanics, nonlinear coupled equations, boundary value problems using the homotopy perturbation method or the regular perturbation method. But right now I am interested in solving all my problem by using the numerical methods. That's why I was interested and I joined this 1 week workshop, and it was really very informative for me. Thank you so much, Dr. Meherchan, for organizing this event.
The success of this event because of the number of participants. When we have the number of participants, really appreciate us to organize this type of event. And also the good thing is that you will be permitted to share your views, your Google Scholar link, or your profile in our numerical method group. Okay, because till now there was no permission, but now today I will permit you, so that we can establish good relations for collaboration. We can work together, because this will be very good for all of us when we have a good team and good collaborations around the world. Then the work will also be very good, and we can contribute very nicely, and we can help each other in many ways. there are many problems around the world, and we can help each other to sort out this type of problems, respective your areas. Okay. Many things has been discussed, but there are many things to be discussed. We will meet in the coming new workshop, and also I will update you very soon for the special session based on basic fundamental of MATLAB, so that if you are facing basics about the MATLAB, so that we can help each other. And also the feedback form I have shared in the chat box, and also I will share on your email address the content, because the last 2 days I have some technical issue due to Google, because we have purchased some product that's why I was not able to send the content through email. So now today the problem has been sorted out, and I will share all the content on your email address. Thank you all of you to be part of this workshop. Thank you all of you. Please submit your feedback if you miss any day. All the feedback link will be shared on your email address. So feedback is very important for us. So it is time to close this session. Thank you very much, all of you, to be part of this workshop. Have a nice day. Good time.
Thank you, sir.
Thank you.
Sir, how can get the certificate, sir?
Yeah, the certificate will be sent you on your email address. I will send your certificate till Sunday evening. Today I will not send. Tomorrow I need some time, and on Sunday till evening, at this time you will have your certificate.
Thank you, sir.
Yeah. Thank you all.
Thank you, sir.
Thank you, sir. Bye bye.
Bye.
Bye bye. Bye bye. Thank you, sir. Bye bye. Bye bye. So let's say bye bye. I know the next bye bye. I bye bye actually in Nigeria.
Thank you so much, sir. Thank you, everyone.